Okay, so we're going to begin. So welcome to the online group course Introduction to EA-PSM Electric. We're very glad that you're attending this event, and we hope to see you soon at our later organized trainings at Autumn. To begin this webinar, we will introduce ourselves. So I am Invitas, and this is Mantas, and we will guide you through this course. We provide a brief segment of a video of the training with EA-PSM. While the video is playing, you can ask questions through the chat that we will answer when the video is done in real time. So I'm going to share the video right now. Let's begin.
This introductory training will teach the basics of using power system modeling software, or in short, EA-PSM. I highly recommend that you follow alongside with this training using our software. In good practice, it is best to follow along and perform the tasks alongside me. Only listening is not that useful as trying one time using the software. If you have the possibility to work with two monitors, it will be much easier to follow the steps. Dedicate one monitor for listening and watching the training and the other one for working with the software. I will try to go at a slow pace so that you can do it alongside me. After this announcement, there will be 30 minutes left for questions, so write down all the questions that have come up and we will happily answer them. To better understand the possibilities and functionalities of the EA-PSM, I want to show you a situation and its problems that we're going to solve. Now, let me show you the situation. The situation states that an industrial plant wants to connect an additional energy source, that is the solar power plant, up to 1 megawatts of power to its system. When the solar power plant is connected, different plant modes must be checked to see if there is no risk of shutdown or malfunction. Those different plant modes should be different industrial plant equipment should be shut off and on to check if the voltage levels at each bus bar are the correct level, the current flows, and if the cable sizing is done correctly, and if no more additional parallel cables should be installed. So the solution is, using EA-PSM software, check various types of network modes and find a quick solution for the problems that may arise. Now I will read the workflow. Draw the given power plant scheme with the given information. Below this page, I have a scheme that is given to me, and we will check if there are many problems and how do we have to solve them when we're installing the solar power plant. As we can see below the scheme, there are transformer specifications that are given, and we were going to input it by hand. And both tabs for transformers are 2.5% plus minus 2. Second, perform load flow calculations and check current flows and cable sizing. When I'm going to perform load flow calculations, we're going to check if the current does not exceed the cable sizing. Perform motor start analysis and check the conditions and determine if there is no need to install capacitor batteries. The reason to install capacitor batteries is that motor start reactive currents are compensated with the help of capacitor banks. That means our transformer is loaded less, our cables are loaded less, and we save money. Also, to connect this solar power plant, we must ensure a reliable system when the solar power plant is on and off. Also, it is crucial to maintain a standard voltage level to prevent any shutdowns or malfunctions of any equipment. Usually, the voltage level is kept at plus minus 10%, the nominal voltage of the bus bar. The fourth, check voltage levels at each bus bar at different operations of the plant. Those operations are: solar power plant is turned off and on, transformer tap changer maintains voltage at approximately 100% the nominal voltage, capacitor batteries are turned off and on, and motor start conditions. And after we have checked all the 4 points, the fifth one is generate a report. The report is a place where all the given information is Very easy to use, and all your clients, when you're done with your project, can watch them very easily and check all the calculations and parameters. Now, I'm going to show you how to model this scheme using EA-PSM. By going to EA-PSM, we can see this white space here is the drawing space. Here, we'll add all our elements and perform calculations. Now, to start, we're gonna add our first bus bar that is put in when starting to work on a project, and it is called the infinite bus bar. As we can see, it is highlighted in gray infinite. It is the equivalent to TSOs or DSOs, and it simulates them. So let's name our first bus bar TSO, and we're gonna pick the voltage that is 10 kilovolts. And as you can see in this table here, there are a lot of voltages that are predefined that are usually used in practice for your convenience. But if you do not find the voltage that you want, simply you can input it by hand and it will save in the program and you can use it for later on. Also, these minimum and maximum voltages indicates when the voltage is over the limit to easily find the fault in your project. At the moment, I'm going to choose 10% and 5%, but if you want, you can change it however you want. We'll press apply and OK, and now we're going to model the scheme that was given beforehand in the situation. Let's pull up this. Okay, as we can see in the given scheme, we must model one more bus bar. So let's do that. When adding the bus bar, you can see that this bus bar was added with the same voltage as the previous one before. When adding bus bars, our software EA-PSM remembers the previously placed bus bar and does it the same at another one when you place it. So let's now expand this. Then we're gonna connect our first infinite bus bar to the secondary point. But I must mention that when adding cables, it is very, very important to know which way you're placing the cable. You have to press on the first bus bar, that is your beginning, and the second one, that is your end. If you input it correctly, then all your data will not be reversed and some calculations will not interfere. Okay, let's add 2 more bus bars. We're gonna connect these with the cables. Always remember what's first, where's the beginning and where's the end. If you see this cable and you want to correct it by not moving the bus bar like this, you can simply select the cable and press on your keyboard Ctrl J. Now you can see that these bus bars are not aligned. You can simply just select them and press X. By pressing X, it aligns by the X axis. So that is not what you want. To align it by the height, you just press Y and it's all good. Now we're gonna align this cable again and let's carry on. Now we're gonna have to use a step down transformer to go to the low voltage side. But first, let's select our 0.4 volt bus bars. And as you may know, certain lines in our program, lines cannot be connected if the bus bars are at a different voltage. Lines, as this one, is a linear model. It can only be connected between 2 bus bars. Linear symbols, as an example, in EA-PSM are line, transformers, shunts, variable frequency drives, and soft starters. The other type of elements are shunt elements. Shunt elements can be connected with 1 bus bar. Shunt element examples are generator, wind turbine, photovoltaic system, inverter, load, motor, capacitor, and many more. But now let's focus on the transformer. Let's add the transformer, and now we have to input its specifications. As I have mentioned before, all the specifications were given in the table here. First, we're going to name our transformer Transformer 1. Then we're going to go to the Configure tab and change all the settings. Firstly, we're going to change the short circuit voltage. It is 6%. Then the load losses, that is 16.5 kilowatts. And then no load losses, that is 0.13%. Then we're going to define the high side voltage, that is 10 kilovolts, and the low side is 0.4, so it's 400, and we do not need to change that. The nominal power is 1.6 megawatt amperes. And the last thing we're going to do is change the taps on the high side. As you remember, it is 2.5%. 2.5, and step up is 2, step down is also 2. Hit apply and OK. And as you can see, at the moment, we cannot connect this transformer because it's not the same orientation as the bus bars. To do so, simply select the element and press Tab. We have successfully added the transformer. Now, the same steps must be taken to add the other transformer. But to add this transformer, it is much easier because we can copy our previously inputted transformers specifications into this one by pressing on the element, pressing Shift C and Shift V on this one, and now we have the same transformer. Now we just need to change the name, that is Transformer 2. Press apply and OK. And let's carry on with the modeling. Here, let's press Ctrl J. Okay, carrying on. Now we're gonna model the low voltage side. We're gonna add one more bus bar. 2 more bus bars to be exact. Connect the cables in the correct way, beginning and end. Beginning and end. And then to this bus bar, we're gonna connect a load and a capacitor. Now I'm gonna define its specifications. Let's start with the load. The load will be 350 kilowatts. 350 kilowatts, and the power factor will be 0.91. Hit apply OK. Now let's do the capacitor. The capacitor real power is 150 watts and reactive power is 150 kilovars. Let's carry on with the second bus bar. We're gonna add a load, and now we're gonna add a motor. We're gonna stretch the bus bar a bit, and if you want that all the elements would be aligned the same distance from your bus bar, simply press on the bus bar, hit right click, graphics, reset item positions. As you can see, the item positions were reset. Now I'm gonna define the parameters. So this load is 500 kilowatts and the power factor is 0.991. That is a perfect power factor that all companies should strive for. The motor, we're gonna select the motor from a predefined table. As you can see, we have a lot of motors that you can select from, but as of now, I'm gonna select a predefined one, 160 kilowatts, 4 poles. Let's hit apply and OK. And as we can see, this side is done. Let's carry on with the second one. Let's expand these. Add a bus bar. Add a load. Add another motor. Let's connect the cable with this one. With this. And now, as you can see, the second element here is a variable frequency drive. Now we're going to connect it to the motor to mitigate the motor start currents that may arise when your motor starts or begins to power on. Okay, now we're going to add a variable frequency drive. One input count 1, output count also 1. We're going to add a motor to it. Then a second motor. Then we're going to add another bus bar, another variable frequency drive. Sorry, this is an inverter. They look, as you can see, they look similar. So it is crucial to not mix them up. But when you add the symbol, it is quite, you can distinct it from the other one. Okay, now let's define the motor. So this motor will be from the table, 132 kilowatts. This load is 600 kilowatts. The power factor is 0.982. Okay, now the motor with the variable frequency drive, it is 90 kilowatts, 4 poles. The fourth one will be 160 kilowatts. Yes, 160 kilowatts, okay. And the last one will be 90 kilowatts. Okay, so now as you can see, we have modeled the basic image of the scheme, but now we must add the cables. To add the cables, simply double click on the cable, go to details, but at first you must define the distance of the cable, the length. So this cable will be 7 kilometers, and you can have the variety of choosing from overhead lines, cable lines, and hand defined if you want. I'm going to choose the cables, and now we're going to define them. So this one will be, it will be in the high side, so 10 to 11 kilovolts. Number of cores will be 4 or more. Let's check 4 or more. Okay, 3 is enough in the high side. So we'll go with this one. And then we must configure the cable ampacity. So we will go with multi-core, armored, buried direct and ground. And we see the recommendation of the installation method type is given to us, 3-core unarmored cable, buried direct in the ground. We'll choose this, select the ground temperature, the buried depth, the ground thermal resistivity, underground spacing, and grouped cables. And let's press apply and OK. And as we can see, the cable ampacity rating is 553 amperes. When all of the variables are put in, then we can press apply and OK, and our given cable is defined. Now I'm going to define all the other cables. Okay, now I have inputted all the cables. This scheme is no longer needed for us. So as you can see, all the inputted cables are as the same as the previous ones. I inputted the type of the cable, I configured the installation method, and got the ampacity rating. Now when we have the ampacity rating, we can connect our solar power plant to the industry scheme. Let's connect it here. As I mentioned before, it will be 1 megawatt. It will be loaded at 100%. We'll press apply and OK. If you want to model in more detail your solar power plant to get more solar panels, you can always do that with EA-PSM, but now we just need a basic information to model the system. So now let's carry out the power flows and check how the cable ampacity rating is doing. As you can see, when there is a red color of your text, it means that the cable ampacity rating, the current flowing through the cable doesn't withstand the cable ampacity rating. That is why we need to add parallel cables or widen the cross area of the cable. But we will do parallel cable solution. So as you can see in here, our cable ampacity rating is 261 amperes, and the current flowing through the wire is 534. So 2 should be enough, or 3, but it is a very small number that varies, so it will be 3. And as you can see, when the cable ampacity is correct, then the red text becomes plain black. We're gonna do with this the same. We have our cable ampacity rating is 300. So in this situation, 3 parallel cables will surely be enough. Yes, and that was correct. And then carrying on, in this situation, this cable was not specified by the cable ampacity rating, but it is quite the same situation, so 4 should be enough. Other cables are all right, but we must note that our system has motors, so we must carry out motor start analysis. EA-PSM software lets to start all different kinds of motors. So if I would want, I could start the third and fourth, but at now we're gonna start all the motors to check the worst scenario possible. Press it again. Okay, as you can see now, we need in some cables the cable ampacity rating should be bigger, but at some bus bars we can see that the reactive power flowing through the cable is 105 kilowatts. So first, before doubling the amount of parallel cables, we should try to compensate the reactive power. Firstly, let's add another bus bar, add a motor to it, then connect a wire with the bus bar where the motor is, and let's add a capacitor. And if we see here it's 105 kilowatts, then we'll add approximately 100 watts and 100 kilowatts. That should compensate the given situation. So let's check. As we can see, it is not enough. So let's just add the equivalent kilowatts to the amount of kilowatts our motor produces. So let's add 166. And now let's carry on with the calculations. As you can see, the kilowatts are a little bit compensated but we still need more. So we'll add 250 and 250 kilowatts. Well, as we can see, it slightly reduces, but at this point, to compensate the reactive power, we should just double the grouped cables. So in this situation, we should add 3 or even 7. 7 is enough, so that is all right. And as we can see, the voltage level is slightly dropped at the bus bar. So that thing should be taken into account. As we can see here, we're generating a lot of reactive power. That should be compensated. We can add even more. See here, even more reactive power is still generated on our cable. That is why we still need to add more. Let's carry out the calculations again. And as we can see, if we compensate the reactive power enough, we can lessen the parallel cables in our scheme. Right now, even 5 parallel cables are enough. Let's check with 4. And still it's enough. Maybe 3 will be enough, but I don't think so. No, so let's stay with 4. So as we can see, now we have solved the problem of the cable ampacity rating and the voltage drop levels in this specific part of the scheme. And yeah, now we have solved the problem of the voltage fluctuations and the cable ampacity. But we must remember, these capacitors should be named motor start capacitor, because we only use them when we're using the motor start. We're gonna put the same here. Let's begin it here. Because if we have the motor start capacitors turned on and we do power flows, we can see that we have voltage rise in the bus bars. That is why we must disconnect them, and then it's all right. Okay, let's carry on to the next problem. We see that at this bus bar there is 143 kilowars. So let's compensate them. To check again, we're gonna do the motor analysis. So we can see here 991 kilowatts are generated, and here is 35. So at the moment I'm gonna add a capacitor battery here. We're gonna use tab as I mentioned before. I'm gonna add approximately 200 watts, 200 kilowatts, and check if the situation gets better. As we can see, still a lot of reactive power is generated that should be compensated because reactive power costs, and we can see our transformer is overloaded, and at time insulation could be defected because of not nominal temperatures. So now let's add more capacitors, or let's just increase this one's reactive power, because this is just a basic simulation. Usually you should add steps in your capacitors, as I will show you in a second. We're gonna add here 800 and check now. As we can see, the situation is getting a little bit better, but now we must add even 1000. And as we can see, the voltage drops are not that bad anymore. And basically we have compensated all the reactive power in the bus bar. So this is another motor start capacitor, and as you can see, the same problem will arise when I'm going to do power flow calculations. Well, maybe not in all capacitor, not in all situations, but usually this should be turned off because it generates reactive power that usually industry pays for. So now we're gonna do this again with the same other motor. Add the bus bar, add this. And then we're gonna check the motor start analysis again. Check how much reactive power is generated. 1.6. So now the voltage has dropped substantially. We see that a lot of reactive power is generated here. So now let's add two capacitor banks that are 600 kilowatts. And now we're gonna check again. As we can see, we have compensated here again, and now the transformer is not overloaded. But now we must check if the capacitor banks are connected when we do power flows. Yes, as we can see, the voltage increases. That is why we must disconnect them, but only connect them when the motor starts. We have found a solution to the motor start analysis by installing capacitor banks and checking all the parameters of our industrial plant. We can check it also by disconnecting these loads. As we can see, still the nominal voltage doesn't go over the limit. If we disconnect, the power plant is still the same. If we do the more analysis and add the capacitor banks, we can see everything is all in shape. We can do a whole review of this whole power plant when it's working optimal. Even we can connect the solar power plant to check, and the loads. As we can see, we don't have any problems in our industry factory. That means that everything can work even at worst conditions. As you can see, using power system modeling software, it is very easy to determine all types of conditions of your power plant. By knowing all the conditions, you know what to expect and what preventive measures you should do to prevent any losses to your company, or always maintain a good runtime of your equipment. This was just a brief review of EA-PSM and its functionalities. We only discussed two calculation studies that are usually performed when using this power system modeling software. As you can see, we have a lot of other studies you can do. There are short circuit analysis, harmonic flow analysis, arc flash, and many more. You can even use the Analyze tab and use transient process, motor dynamics. You can model wind turbine power quality. Relay coordination and protection tracking are in beta, but you're free to use it. And installation coordination and even cable reports. So EA-PSM has a lot of functionalities, and I only scratched the surface. So if you want to know more about EA-PSM, we're eager to wait for you when we are going to organize the events in autumn to more moderate experience and to get higher qualification. And we hope to see you there. But now, given all the calculations we see here, we have to export it to the project panel. And I'm going to show you how to do it now. When you're done carrying out calculations on your given scheme and you don't want to do the calculations 2 times, in the upper toolbar you can see there are a lot of pictures. The first one is display power flow results. That is, if you have carried out power flow results previously, you can press and check the results that was before. If you want to go back to motor start results, you just press motor start. Now, when we are done modeling our scheme, the next thing we should do is generate a summary in the project panel. By going to the project panel, first thing we should do is take a screenshot of the given scheme. So let's do that. Screenshot it in any way you want, and then simply just press Ctrl V on the scheme and the picture will come up. Now we can just make it a little bit bigger and leave it here. Let's do this and this, and let's leave it here. Now let's screenshot the other side of the scheme, the grid. Let's copy, go to the project panel, again paste it, decrease the size a little bit so that it would fit in the model. And now, when you have added your photos, you can right-click on the project panel, and there is a lot of things you can add, such as text, scheme view, charts, tables, images. So now I'm gonna paste a table in that is from summary, AC electric, and the buses that checks the voltages. But now we're seeing the results when all the capacitor batteries are turned on. That is a thing we do not want. And also we can change the parameters that are displayed, such as substation, the percent, local power, output power, input power, and we are left with the specifications that are needed for us. But now let's change the voltage levels. To do that, we need to disconnect the motor start batteries because they are only for motor start, and let's carry out power flow. As you can see, all the parameters are good. Let's go back to the cable report, and as we can see, the table has been updated, and now we can add more tables and more results to later on print it out and show it as a final product. Now I'm going to add all the other tables in a few minutes. As you can see, I have changed the project panel, and I have added more information about it. So as you can see, I have changed the power flows, the pictures that when the capacitors is off, and that is the correct scheme, and all the information is here. Motor start simple, and all the buses and its voltages, and the consumption of the motors. Then the capacitor information, the PV system that we connected information, the cables overview, the motors, and this is the whole report that would be printed out. However, this report is not finished. As we can see, we have a lot of blank spaces here. To edit this, simply double click on the space in somewhere here and go to title block. Then you can input information that is needed, such as name, username, not username, surname. Copy and paste this. Responsible department, energy advice. Use the logo. Also, you can use whatever logo you would like. But simply press browse and input it here. And then the title is Introduction to EA-PSM. Press apply and OK. As you can see, all the information is given here and in all the pages. When you're done finalizing your project panel, simply press here on the far left corner PDF, then choose where to save it, and press yes. When you're done exporting, you can check it on your computer. 1 second, I will show you. Okay, to carry on, I will show you the printed report. Simply go here, expand it, and as you can see, it is the same information that I have inputted in the project panel. That wraps it up about our training. We hope that it was very informative and you learned something new. We always strive to update our program and get the best user performance, and we are always eager to help you. You can write us at our support at EAPSM.net, or if you have any information, it is info@EAPSM.net. We are very happy that you listened to this online group course, and now let's head to the Q&A section. We are very eager to hear your questions, so let's begin.
Hello. So we received several questions already through the presentation. So we can quickly go through some of those questions because we think that they are important to present to all of you. So my colleague will scroll a little bit to the beginning of the chat. So first of all, there were questions like, is it possible to use any voltage level with our software? So technically, yes, user can add any voltage level bus bars. Of course, for some of the voltages, you may need special models, and if those models do not exist in the software, you can always contact our team. We are a lean company which can add additional models very quickly depending on what you need for your project. Also, there was a question about whether generators, grid, or other sources will be analyzed in this training. So as you see, we look through photovoltaic system generator, but it is also possible to model synchronous generators in load flow and short circuit studies. Also, we have wind turbines, for which can be used for harmonic flickers and similar analysis, like for voltage quality, for example. So let's see what were the other questions. So about the input data, actually whether it is possible to select these kind of like, for example, cables, overhead lines from the library, or each element should be specified by hand by inputting impedances. So actually we have library for cables, AC as well as DC cables, from 110 to 0.4 kilovolts. But for other elements like transmission lines, user can also select elements from the library, as well as user can input models into library. So software allows to create any model, for example, for overhead transmission line, so for the line as well as for the tower, as well as for the cable, user can actually add a model by himself. So the next question was also about the models, and there was also a question about protection coordination. Actually, as I remember, there were a few of them. So our software, one of the main functionalities is protection coordination. So when we create a single line diagram, which you can see here on the screen, so we can do calculations like power flows, short circuits, but these are only the main calculations which are needed, for example, to prepare a report about protection coordination, because for protection coordination you need results of power flows as well as short circuits, also motor starting. You can see motors here in the scheme. So protection coordination is one of the main and the most important functionality we have, and definitely user can do this kind of studies with our software. Technically, protection coordination also allows to do calculations like arc flash analysis. After you do protection coordination, you can do arc flash analysis. And what are the possible protection types? So mainly various functionalities that have relays. So it's overcurrent, over voltage, under voltage. Also, we have directional and non-directional protections. Then we have ground fault protection, so various types. Then molded case circuit breakers, miniature circuit breakers, and all the other protections that can be used and that are needed for selectivity study. There are some protection types, like, for example, generator protections, which are not used in selectivity studies with other protection units, for example, like frequency protection devices. So our software have not transient. We do not have transient analysis currently. So technically, with this software, you can do stable mode analysis, which covers power flows and short circuit calculations. So let's see what were the other questions. Yeah, so for protection coordination, as I have mentioned, there was a question if it's possible to analyze tripping. So technically, it's possible automatically. We have selectivity analysis functionality, which allows to calculate tripping of protection devices and actually change parameters, settings of protection devices, so to maintain a correct operation of protection devices. And of course, you can do this by hand selectivity analysis. By analyzing tripping curves or TCC curves, which is most commonly used in protection coordination reports. Let's see what were the other questions. The question was about methods used for load flow study. So we use accelerated Gauss Seidel method, but this software also calculates not only electric but hydraulic networks. So we also know Newton methods. So technically we can apply any method for calculation which you need. Of course, you need to contact us for different methods to be used in load flows. And talking about the about the size of the network, so we have experience working with bigger than 1,000 bus electric networks. We have experience with working bigger than like 5,000 and even more buses of hydraulic networks. We call nodes instead of buses in hydraulic networks. So software is actually capable to work with big networks. And we also have GIS functionality. So GIS functionality allows to activate maps and also draw single line diagrams directly on the map. And we have some new questions, I see. So one of them is scheme drawing is in I direction and X direction.
I can show you.
Yeah.
It is the same as drawing it in the Y direction. There are three models. There is the horizontal and the vertical and the horizontal one. So let's choose the vertical one. Hence, let's add another bus bar. So it's an analogy to drawing in the Y-axis. So in the X-axis, it is the same.
You of course can connect both of those networks. So you can draw a line from a horizontal bus bar to vertical bus bar to create any model. Here is also a node symbol if you do not need to represent the bus bar. So user can actually create a lot of different icons for elements. In this version, user can even draw icons by himself by hand. So yes, it is possible to draw a scheme in Y as well as X direction. Another question, can this software run DC load flow simulations for railway? And can we determine the DC equipment sizing? So technically, yes, we have DC analysis functionality. So I will open the DC elements panel. So it is also possible, as well as in AC network, user can add nodes which represent plus and minus nodes. Also cable DC line. User can select the cross-section diameter of the DC line, and then there are elements like DC load, grounding. Also, there is PV module, photovoltaic module, as well as photovoltaic module array, battery bank, voltage source, as well as protection units. So user can create any DC network and do analysis as well as for the railway. It would be possible. So actually a good question. And Ali, you can also contact this for more details. Contact us for more details. Then there is one more question. We are currently working on a solar integration project, and we are facing some issues. Could you help with it? So I'm not sure. Are you working with our software, or you are doing without the software? But of course, it would be best that you can contact us directly. So we have a lot of experience working with DC integration projects. So my colleague Minvidas will show you our
where if you have any questions about any related project, you can go to our website EA-PSM.net, go to the urgent assistance tab, left click on it, and here will be all the information that you need. We provide project analysis and technical assistance as assistance to regarding EA-PSM software usage. So if you have any questions, you can write at us at info@eapsm.net, and we can provide you what consultation would you need.
Then there is question about the demo version for self-evaluation. So Minvidas, can you open the site again? So in the site, you can also try demo. You can see this button on the right side for capability to contact you and maybe talk more about using the software, explain how to use the software. We are asking to provide some contact details, only the name and email. And when you will provide this data, you will get the link to download the demo, which will allow you to do most of the functionality. Except maybe with limited number of buses and some limited export capabilities, but most of the functionalities will be there in the demo. You will also get example schemes that you can try and work with.
So one more question is, can you share the recording with me? And of course, when this presentation is done, there will be a possibility to get the recording of this webinar. If there are any more questions, feel free to ask. We have some more time.
Well, we see that there are a lot of good questions, especially if you have some project which is related to power system analysis. So now after this video, I think that you should know a little bit what is possible to do with our software. So in most cases, the best way is to contact us directly with your question. We can organize some online meeting. Face-to-face meeting is also possible if you are from Lithuania, for example, or country near around. So, and we can discuss those questions directly and see how this problem can be solved using EA-PSM.
And how to get the recording when it's done. When the recording is done, we'll send you an email about the brief information about the webinar. You can leave a review. How do you like it? And you can get the demo version, the recorded video.
If you are not registered maybe and connected to Zoom, so you can also leave your email here in the chat.
Yes, and then we will contact you.
Maybe we can go back to one question regarding solar integration. There were a question about the solar integration study. Let's leave the software opened. So technically, when you do solar integration projects, the main thing you need to check is voltage levels in the network without the solar power plant and with the solar power plant under operation. So for example, in this network, user can also specify time series of solar power plant. So during the night, of course, it will generate zero power. During the morning hours, it will generate maybe 30% of its power and so on. So it's possible to specify time series of, for example, 1 day or even 1 year of solar power plant operation. And it is possible to perform calculations with solar power plant connected to the network. This will allow you to get information about the voltage levels in the solar busbar. So the busbar where the solar power plant is connected. And of course, when the solar power plant, for some reason, for example, for protection, tripping, or other error is disconnected, so voltage level in the network will be different. So it is very important to check how much different it will be, because this will affect other consumers connected to the network. So we can see that without the solar power plant, the voltage level is around 98.3%. When the solar power plant is connected and we launch the power flow calculations, voltage level is 99.4%. So it affects voltage in this bus bar about 1%. Of course, this voltage will increase currents in the whole network. Will consumers like motors, lighting, other type of consumers will also be affected by this voltage variation. So then there are actually standards, several standards which specifies what is the permissible level of voltage fluctuations created by the solar power plant. So user actually have to analyze how solar power plant will affect the voltage in the network. And of course, it is important to check whether transformer will be capable to transmit the power. For example, if loads are disconnected, yes, and only solar power plant is working, so whether transformer will be capable to transfer all the power from the solar power plant. We can see that numbers are in like black color, which means that yes, transformer will be capable to transfer this power. Of course, we have to check protection coordination. So if loads are disconnected and solar power plant is generating over 1.4 kiloamps, so this breaker should be capable to withstand this kind of current. And now I can see that it will trip after about like 20 seconds. So we have to change the settings of this breaker, or even to choose the bigger nominal breaker from the library. So here's the library of different circuit breakers that are used in low voltage networks. So for example, we can take some other protection device. You can see that we can change settings of the protection device, and actually we can create selectivity charts where it is possible to see protection device curve as well as load flows curve, also a cable or transformer, in this case capability curve. So according to this, we can size the correct protection device. So various studies have to be done to connect solar power plant. And maybe the last one, which was not analyzed in this brief seminar, is about the harmonic flows. So it is also possible to analyze what are the harmonics created from the solar power plant and how they will affect the network. This would be a brief introduction about the solar power plant. Let's see what are the other questions.
And I can see there are more questions, so we'll answer them.
Yeah, so the question is, can we create a library for different equipment? Dynamic models for solar and if dynamic models for solar is available. So about the libraries, I quickly will show you what are the possible libraries. So if we take AC electric networks, so you can create library for cables, wires, towers, transformers, generators, motors, motor loads. So for example, fan, pump, or different mechanical loads. Then circuit breakers, overload protection, motor circuit breakers, surge arresters, and advanced cable type modeling. So basically these are main models that you can create in our software. Then about the solar dynamic models, it is possible actually to analyze solar generation. So here in Analyze tab, it is possible to calculate solar irradiance So basically, you need to specify the location of solar power plant. You can load the sample data, or best choice it would be, of course, to add data from your computer. So actually, we need information about the solar irradiation in that location. And actually, it is possible to select inverter from various inverters, select PV module. So we have a broad library. Maybe in this version, the library is not included. So technically, you can specify it by hand. Then also it is possible to specify tilt angle, azimuth angle of the solar power plant. And this information should allow you to calculate radiance in hourly, daily, or yearly basis. So of course we need the PV modules to be loaded. Oh, okay, I can see that these are already loaded. So there are over 15,000 PV modules, different PV modules included in the library. So we can select actually any of these. As for example, we can select, let's say, 5 modules, 23 modules in series, and for example, like 5 modules in parallel. This will be around 30 kilowatts in total, and we can select 3 inverters, 10 kilowatts each. So after this is done, we get information about the solar irradiance, module generation, also Sankey diagram, which represents how much power is injected into grid. So technically, this information can be used for analysis, but all the analysis is like in a static steps. So software calculates if you have time dependency re-specified. Software calculates each step separately. So it's kind of dynamic analysis, but depending on your needs, other functionality might be important for you. So let's see what are the other questions. Is the software same as ETAP? The question here is, so ETAP also performs electric network analysis. So basically, ETAP have most of these elements as well. So technically, with this software, you can perform most of the functionalities which are included in ETAP. So it's not the same, but it's similar. We could answer like this.
Next question is, if model is already prepared in Y direction, can its orientation be changed in X direction? Well, this functionality is not included.
Actually, you can change, yeah, because when you do the model icon symbol, so user can draw a model in any direction, and by a tab button, it is possible to change actually the directions in the network. So user can technically change how the element is connected. So if I connect, I can also connect load, for example, to vertical bus bar, and we can see that it's in vertical direction. Then with tab, I can change it to one side or another. When I connect a load to a horizontal bus bar, so it's in horizontal orientation. So user can also create models by hand and draw this in any direction. So it works in both directions. Let's see other questions. How many nodes do I need to evaluate an impact of connecting renewable sources to existing grid of a small town? So technically, it depends how far the solar power plant is from the main transformer substation. If it's very near or even directly connected to bus bars in the substation, so technically you do not need to specify the whole town network. Actually, you need to only specify a network from the substation to the solar power plant. So in this case, like up to 50 buses would be enough. Of course, if you want to create a distribution network in that town, so you might need much more buses, but always it depends on how detailed analysis you have to do. For voltage quality analysis, most commonly it's enough to to create a single line diagram of the substation and the network from the substation to the solar power plant, and this will allow you to get most the results you need. Then there's a question, can we calculate a ground wire cross section or perform a grounding device calculation in the EA-PSM? So grounding calculation is not included in the EA-PSM. So this functionality, yeah, we know. We had several requests already from the clients. So maybe in the near future we will start developing, but in this version, grounding analysis is not included. What about the multiple scenario studies in each study? So technically in our software, we have a so-called snapshot system, which allows to analyze multiple scenarios. So technically in this snapshot system, which is activated here next to the elements tab, user can create like same network, but different working modes of that network. So for example, I can add a coupling line from one bus bar to another. So let's say in the main scenario, this coupling line is disconnected, but I can also connect additional scenario, like let's say I'll call it snapshot 1, where this coupling line will be connected, and for example, one of the transformer will be disconnected. So now the whole network is fed from network through one of these transformers and through the coupling line. So when I'll go back to default mode, I'll see that this coupling line is connected. I can disconnect it like this, and technically a user can create different network scenarios. So here we have two transformers connected and coupling line disconnected, and here we have coupling line connected and this transformer disconnected. So when you clear, it's very important to have this functionality when you create the project panel report, because in the report you have to provide the results from different modes, from different snapshots, and it allows you to select from which snapshot, for example, you want to provide the results. So only by changing in options from which mode you have to visualize the results. So it's possible to analyze several network scenarios in one scheme. Yeah, so different loading conditions, different generations, generation conditions also will be included. The question is, can we import CSV file for solar irradiation? So definitely yes, you can import CSV file. If you want to import this data for solar irradiance modeling, so first I would recommend to export the header file. The header file will show what data you need, and accordingly you will be capable to provide the needed data. Also, if you want to provide the solar irradiance, for example, directly in a PV module, so you can just simply copy and paste data from a CSV format file using like your keyboard, Control-C, Control-V, and the data will go automatically into this tab. So there was a question about solar irradiance. Okay, so
if there is no more questions, I think we're going to wrap this up. So if you have any question for the last minute, we're waiting. And if not, we're going to close this webinar. Okay, I think we're going to wrap up this webinar. So thank you for listening. I hope this was informative. Yes, and I urge you to visit our website, EA-PSM.net. We have a lot of things put in here. You can check the plans and pricing of our product. As you can see, it is the price is very flexible, and you can select the plans with how much bus bars you need in your project. And after this webinar, you'll get an email with all the information about this webinar, such as the recording. And if you want, you will get the certificate of attendance, and you can review this webinar. So I thank you for listening, and goodbye.
Thank you all. And for more questions, please contact us directly so we can discuss it in more detail. So thank you all. Email.